Alright, Chapter 5, Section 6, Geometry. Inequalities in a triangle. Okay. Comparison inequality, property of inequality says this. If uh, A is equal to A plus B, B plus C, and C is greater than 0, then A is greater than B. So if A is equal to B plus C, and C is greater than 0, then I can say that A is greater than B. So here's how this works with the proof. So essentially we're saying that the sum of two guys, these two guys will always be less than whatever it's equal to, um, given the fact that C has to be greater than 0. Notice it does say greater than or equal to. It has to be greater than. We start off with the fact that C is greater than 0. If I was to add B on both sides, so this is going to be C plus B greater than 0 plus B. I'm adding B to both sides, so this is going to be C plus B plus 0 plus B. Alright? So we're adding B to both sides. C plus B is greater than 0 plus B. Adding B to both sides. This is the addition property of inequality because we're dealing with the inequality symbol. So addition property of inequality. Addition property of inequality. Well, 0 plus b, or 0 plus anything, is it's itself. So for the third step, it's going to be c plus b is greater than b, which is the identity property of addition. So identity property of addition, because 0 plus b is b. We also have this other given here. We have that A is equal to B plus C. Given. So let's look here. I have B plus C, I have B plus C. I can substitute it in. I can't use transitive because I have an inequality symbol here and I have an equal symbol here, so that's not going to work. So the only thing that I can use is substitution. I'm going to substitute A for B plus C. So for my fifth step, I'm going to have A that takes the place over B plus C is greater than B. Substitution. So what does this mean in terms of triangles? Let's say we have a triangle A, B, and C in terms of angles. It also works in terms of sides as well. I'm just using angles for example. We know that, actually no, let's do it this way. They're going to do it with exterior angles, so A, B, and C. The exterior angle theorem says that A is equal to B plus C. These guys can't be 0 because there's no such thing as negative angles. Which means that either A is going to be greater than B or A is going to be greater than C, using this comparison property of inequality. And that's exactly where we go to right here. Corollary to triangle exterior angle theorem. If angle plus angle 3 then angle 1 is going to be greater than angle 2. Well, we'll go to measure. Well, the measure of angle 1 is going to be greater than the measure of angle 2, and the measure of angle 1 is going to be greater than the measure of angle 3. Okay, so they have a proof of it, and they're going to use the comparison property of inequality to prove it. So for this triangle, we can say, this is the proof, I'm going to use it as a 2-column. Angle, the exterior angle theorem, measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3. The measure of angle 1 is greater than, 2 rather, is greater than 0, and the measure of angle 3 is greater than 0. That's going to be our given. So that's our given up there. I'm going to write all of that down twice. Okie dokie. Next step, just like the comparison property of inequality from the previous section, I can say that since that's my given, I can say that the measure of angle 2, I'm going to write two folds, the measure of angle 2 plus the measure of angle 3 equals 0 plus the measure of angle 3. I can say the measure of angle 3 plus the measure of angle 2 equals 0 plus the measure of angle 2. And that's going to be because of the addition property of inequality. It's going to be the same exact thing on the left hand side. We're just using different letters and numbers. Then I can say that the measure of angle 2 plus the measure of angle 3 is equal to the measure of angle, I'm sorry, not equal to, is greater than my brain. It's greater than the measure of angle 3. I could say the measure of angle 2 plus the measure of angle 3 is greater than the measure of angle 2. Identity property of addition. Alright, then we have that other given. The measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3. They give it to us. Alright. Since 2 plus 3 is equal to this guy and 2 plus 3 is equal to that guy, I can sub this for that, and I can also sub this for that, and for two different statements. So my last statement would be B, the measure of angle 1 is greater than the measure of angle 3, and the measure of angle 1 is greater than the measure of angle 2. Substitution. So it's the exact same reasonings as the comparison property of inequality. We're just using two different angles and as substitution, but it's the same exact process. Okay, so they have a question here. Why is the measure of angle phi greater than the measure of angle C? So they throw these are a whole bunch of triangles out there to throw you off, but I'm going to show you what they want you to see, but they're tricking you to not see. Ignore all of that other stuff. Just look at 3. And just look at C. And then we have 5. So remember, the exterior angles theorem says that the measure of angle 5 is equal to the angle 3 plus angle C. We just proved that, and we know that C is greater than 0 and 3 is greater than 0. We just proved that whatever it's equal to is going to be greater than because of the corollary to triangle exterior angles theorem. So we know that angle 5 is greater than angle 5 is greater than angle C. God lordy. Yeah, it's better to put the measure in front. Because of the corollary to triangle angles theorem. That's all they wanted. They wanted you so they threw this other stuff in here. A was part of the problem prior, but they also wanted to sort of throw you off, so that you wouldn't see it. Now that you put all that other stuff in there, now you can see it better, right? All right. Theorem 510. This is and 510 and 511 are theorems that we're going to use a lot with triangles. If two sides of a triangle are not congruent, then the opposite larger angle, then the larger angle lies opposite the longer side of it again. If two sides of a triangle are not congruent, then the larger angle lies opposite of the larger side. So what does that mean? In a triangle. Hank. There you go. Trying to do this so that it works out. Let's see if I do. Just go that way. Okay. This side is the largest side. So the angle opposite of this guy is going to be the largest angle. That's what this says. So X, Y, Z. We have side XY. Actually, do it this way. We also have this other angle here, which is not as large. We have this other side here. Okay. What theorem 510 says is that since XY is the larger side, then the angle Y is going to be greater than all the rest. Since XZ rather, since X is Y is the second largest or the smaller angle, then smaller side, then the angle is going to be smaller. So what does that mean? Since XZ, keep saying XY. Since XZ is greater than XY, XZ is greater than XY, this side is longer than this side, then I can say that the measure of angle Z the measure of angle Y, because it's the guy opposite of them, is greater than the measure of angle Z. Y is opposite of XZ, so XY is the larger angle. Z is opposite of XY, so Z is the smaller of the two. The larger the side, the bigger the angle. The smaller the side, the smaller the angle. The smallest side, the smallest angle. The largest side, the largest angle. The medium side, the medium angle. Always. Here is the reverse. So we have we have these triangles. Oh yeah, that works. Here's this side, and here is that side. So this is the theorem 511 is basically the converse of this theorem that we did from 510. ABC. And it does the angles instead. This angle and this angle. Okay, so now instead of saying the larger side, the larger angle, now we're going to say the larger angle, the larger the side. So if the measurement of angle A is greater than the measurement of angle B, then I can say that side BC is greater than side AC. Angle opposite, or side opposite. The bigger the angle, the bigger the side. The smaller the angle, the smaller the side. Okay. So we can use that to solve various problems. So it says in this figure we have triangle SOX. They say that S is 24 degrees. O is 130. Which side of XOS is the shortest side? So I can subtract 180 minus these two. So 180 minus 30 is 50. 50 minus 24 is that's 16. 26. 26 plus 24 is 50. Yeah. So, which one is the shortest side? It's going to be side OX. And the reason why side OX is the smallest side is because it has the smallest angle of the three. Yep. Smallest angle has the smallest side. Okay. The triangle inequality theorem, theorem 512. And what the triangle inequality theorem says is that the sum of any two sides of the triangle is greater than the third side. So if I have a triangle, X, Y, and Z, then side XY plus side YZ has to be greater than side XZ. Side YZ plus side XZ has to be greater than side XY. And side YZ and XZ has to be greater than side YZ. So, okay, all three sides have to be greater than, the sum of the two sides has to be greater than the third side for a triangle to be a triangle. Otherwise, you won't have enough. You won't have enough to have my triangles come together. So, the third side has to be greater than the sum of the other two sides. Otherwise, you don't have enough length to have a triangle come together. Alright, so the way that we do this to solve these problems is that we need 3 iterations. Here they give me 3 sides. 2, 6, and 9. And they want to know, is it enough? Can I make a triangle out of this? Well, we have scenario number 1. We'll add 2 plus 6, and it has to be greater than 9. We'll check that out later. Scenario number 2. We'll have 2 plus 9 has to be greater than 6. Scenario number 3. 9 plus 6 has to be greater than 2. Well, 9 plus 6 is 15. 15 is greater than 2, so that works. 2 plus 9 is 11. 11 is greater than 6, so that works. 2 plus 6 is 8. 8 is not greater than 9, so it doesn't work. So this is not a triangle. They will not add up. All 3 scenarios have to work in order for me to say that, hey, I have a triangle. For over here, I have 4, 6, and 9. We'll do our same 3 scenarios. 4 plus 6 has to be greater than 9. We'll check it later. 4 plus 9 has to be greater than 6. And then 6 plus 9 has to be greater than 4. 6 and 9 is 15, which is greater than 4. Hallelujah. 4 plus 9 is 13, and 13 is greater than 6. Hallelujah. And 4 plus 6 is 10, and 10 is greater than 9. Hallelujah. So this works. So we do have enough to have a triangle. So this is a triangle. Yay. Okay. And then here, as for possible side lengths, so they're going to give us 2 of the sides, and we have to find the range of the third side to see if we can have enough to make it fit for a triangle. So for this one, we have 4 and 7, and we have to find what the third side could be. It can be a lot of numbers. So the way that we do these problems is that we have to find the range. We have to find the biggest number it can be and the smallest number it could be. And we do this by doing the 3 scenarios. So scenario number 1, 4 plus 7 has to be greater than x. And we're going to revisit that in a second. Scenario number 2, 4 plus x has to be greater than 7. We'll revisit that in a second. And then scenario number 3, 7 plus x is greater than 4. So basically we're solving for x in all these 3 scenarios. I add 4 and 7 together and I get 11. So x can be less than 11. So I'm flipping the sign here, following the x. So x is less than 11. So that's the biggest it can be. Over here, what in the world? I'm going to subtract 4 from both sides, and I can have x is greater than 4. So that's the smallest it can be. It can be no smaller than 4 and no bigger than 11. And then we got this last scenario. Subtract 7 from both sides. Its x is greater than negative 3. A side of a triangle or an angle cannot be negative. So this is an invalid number. Can't be a negative number. So I have my two scenarios. X is less than 11 and X is greater than 4. That's the number that my guys can be. And it can be anything in between. 5, 6, 7, 8, 9, 10, 10.4, 10.3, 5.6. Any number in between 4 and 11 is what X can be to make this work as a triangle. And that is our section. I hope you have a great rest of your day.